And in recent years, China has caught up in this regard. Tomorrow, Pan-Africa is going to be put into use. It is going to help us bring clean energy to China, and it is also going to make a solid guarantee for China's energy security. Now we are on site, bringing to you Mr. Huang from CNOOC, who is in charge of LNG business, and he's going to give us some introductions of the past and the present of this gas carrier and some technologies. Hi everyone, I'm Huang Guoliang from CNOOC. Now this gas carrier that we are looking at is actually called Pan-Africa, and it is going to be delivered tomorrow officially and put into use. It has been built for 30 months. The total budget is over 1 billion RMB, and the total hold capacity of the carrier is 174,000 cubic meters. So this hold capacity means that if all the LNG is gasified, it is going to be around 100 million cubic meters of natural gas. It can sustain the use of 600,000 residents for a year. And the molded length of this vehicle is actually 290 meters, and its size is similar to that of the aircraft carrier Liaoning of China, and its deck area equals to 32 basketball court. You can say it is a jumbo on the sea. So why we are building this kind of LNG gas carrier, and what's its use? So when it comes to building such a jumbo on the sea, the total area, the total tonnage, China has already reached a very top level in the world. In shipbuilding business, this kind of LNG gas carrier is without any doubt the crown jewels. It is very difficult to build such a carrier. It's with high added value. Previously, only countries such as the US and France and other countries they can build such vehicles, and later Japan and Korea took the baton. And now, with several years of efforts, China has achieved a lot of breakthroughs in building such an LNG gas carrier. With several years of efforts, when it comes to the quality of the shipbuilding, the time, cost, and our budget of building such a vehicle, we are as good as Korea. And now Korea and China are the two countries, the two go-to countries for such a shipbuilding effort. You can look at the tug here, TUG. So for a major vessel like this, it is such a jumbo on the sea, and sometimes it's very difficult for the ship to be steered in the right way into the port. And this sign here is the positioning. And of course, on this position, you have to really strengthen the surface of the vessel. So what is the most challenging part in building such a ship? And what are the challenges you have met in the process of building this giant jumbo? And you can look at the shape of this gas carrier. It looks beautiful. With our own efforts, we have done a lot of optimization of the surface, of the contours of the ship carrier, and we have been able to improve the propulsion efficiency by 10%, and we've also cut down the energy consumption and bring up the energy efficiency of this vessel. We have proprietary design by ourselves, and we've also done a lot of optimization in Sweden, And for the tail axle, it has also been optimized so that the propulsion efficiency can be boosted. Because this is a LNG gas carrier, the materials we have used for the hold cabinet is actually a special steel, and its width is depth is only 0.7 centimeter. Previously, it is very difficult to produce such material in China, and we have to rely on introducing such technologies abroad. And for the wielding process, it is also very difficult. So all these craftsmen who can perform successful wielding on this special steel material are enjoying allowances from the State Council of China for their craftsmanship. That's very rare. We've also seen that for such a core material, China has really caught up. And when it comes to the hold space of the ship, we have also added some insulation layers. And we need to also make sure that there can be certain pressure difference. And actually, you cannot feel it with your hand, for example. So the pressure within the hold space, there will be a major shield, and there will also be a secondary shield. And we have to maintain a pressure difference between the different layers. And we are using nitrogen as a filler to actually achieve such a pressure difference. So nitrogen is being used. So the purpose is to actually provide some insulation. Yes. During transportation, there will be some gasification, there will be temperature change, and sometimes there will be sort of ballooning effects when the temperature is up. In order to make sure that the temperature differences are maintained in the right place, and we have to use nitrogen to make adjustments to the temperature, to the pressure difference. We can also find there are still some facilities on site, and there are still some materials to be uploaded to the ship, because it is going to be delivered tomorrow, right? Yeah. This is a multinational project. This ship has adopted engineers from around 10 countries. There are engineers from the US, from the UK, from India, from Malaysia, South Korea, Ireland, etc. We have really brought power across the world in terms of R&D and management. So when it comes to project management, because this gas carrier from the technical side is very demanding. Previously, when it comes to project management, China is not that good compared with some of the best in the world. Through this process of building this jumbo, we can actually get some opportunities to improve the capacities and skills of our own staff, and we can also take advantage of the R&D powers of other countries. So now we are taking this passage to the ship. This is more like a gangway, you can say. Just now we mentioned the molded height of the ship. Actually, there is another 10 meters under the surface of the water. So the molded depth is 26 meters. That is like a 6-floor building. It's that high. When we come to this position, this is actually the major deck. And when a ship is being parked into a slot in the port, we have to use this facility. As you can find, we have the cables in blue color. It looks very thin, but actually you can have a weld gas for such a cable. How much pressure, how much stress it can sustain. So my recollection is it is much stronger, not this thing, right? So it is just like something that you can wrap your hands with. It can actually sustain a strength of 115 tons. So usually for a sedan car, that is 1.5 to 2 tons. And use this, you can actually uplift a sedan car. So this is a really high strength cable, 115 tons. So when we look at the appearances of this the facility, it looks very tacky, and we can actually go further. So for the most important equipments and facilities, they're mainly inside the cabinet room. So this is the deck for lifesavers, and you can find all the lifesavers equipped on this gas carrier right there. So how many staff, how many crew members are on this gas carrier? Now we have 42 people in the cabin, so that means it is around 40. You have the captain. Of course, you have all the staff for the deck, staff for the engine room. What makes this carrier different from others is that we also have a operation session for all the uploading and for all the loading of LNG. So this is the lifesaver. It is also fireproof. When there is emergency, it can be put in the water automatically. And you can also find there are some climbers that you can use to climb up to the ship. For such a jumbo to be parked in the slot of the port, sometimes it is very tricky because you have no idea what is the hydrological conditions of that port, and sometimes you need to have a navigator for the parking of such a big ship. It's just like a navigator, exactly. And usually that person is more familiar with the hydrological conditions of the port and also the parking route. And sometimes we can also have other staffs climbing all the way up through the climber to the ship deck. You can go this way up to the top. This is a human-oriented design. As you can find, this is actually a finish that can keep you from falling on the floor. So you won't fall off accidentally on the floor, because usually when you are sailing, it is likely for you to fall when there is a lot of humidity. This is the top of the hold cabinet. This is a special design. During transportation, the ship is moving, of course, and the liquefied natural gas will be flowing inside the hold space, and we need to prevent that from getting too volatile. And there will also be some sort of vaporization, and we need to also minimize that. So we adopted the design like this. The shape of the host space is designed like this. We can go up there and take a look. You can put on the gloves. So now we are on top of the host space. Yeah, this is just like a dome deck. It is just like a dome. So what I feel like is that you have two balls being coupled together. The reason why you design like this is because you want to have more host space, right? Actually, it is about the special conditions of LNG, and we want to reduce the vaporization rate of the LNG. So you have to keep the LNG at a very low temperature, right? You have to prevent evaporation, right? And we can't see through, right? No, we can't. Now, what's below is actually a hollow cabinet, and there will also be a layer of insulation below it. And beneath it, there will be a major shield. So that is basically the structure. Now you can find some pipelines on the deck. So this bigger one is the lower temperature pipeline. And of course, there will be an insulation layer on the finish. Some insulating materials are being used. So what is the purpose of having insulating materials here? Because you have to maintain the LNG at a minus 162 Celsius degree. You want to prevent gasification. You want to prevent temperature up, so you have to provide such an insulation layer. So how many tanks do you have for the gas? Now this one, as you can see, it is a pole, and you can find 4 of it. That means you have 4 tanks. Just now we mentioned the total capacity of load is actually 174,000 cubic meters of LNG. And we sort of slice and dice that total capacity into 4 different tanks. But the first one, due to the space limitations, it is the smallest one. But for the others, the capacity mainly is about 40,000 cubic meters. This is a ventilation. So all the LNG will be stored just beneath us, right? Actually, it is the freight cabinet, and later you can find out about all the core facilities and the components. This is the loading and unloading system. We also have a crane here, which is to help us conduct some basic operations. Sometimes you also need to add some fuel, diesel, or heavy oil for the gas carrier. So you have some pipelines here. So the loading and unloading of LNG will be going through these pipes, right? Exactly. So there are 5 different pipelines. You have a bigger one in the middle, and you have smaller ones on the peripheral. And for the bigger one, that is mainly gas-phased. And for the smaller ones, they are the liquid-phased pipelines. And we will make all these pipes joining together into one pipeline. So what is a gas phase pipe exactly? Because we are loading LNG in liquid phase, but due to some influences of temperature or the process of pumping the gas, there will be some gasification happening. So for the gasified LNG, they have to go through the gas-phased pipe, and they have to be repumped back to the port. So there are 8 pumps on this gas carrier. When you are unloading, they will be at work. So for each one, it is roughly around 1,500 cubic meters. It takes more than 10 hours for the ship to be loaded or unloaded. So it can sustain the gas use of 600,000 people a year, right? Exactly. Can you tell us why you want to liquefy the natural gas to transport it? Why is that? Now, the gas consumption in China, usually when it is consumed, the gas is in gas phase. But sometimes it is not enough. I mean, we have to import more natural gas from other countries because China's own production cannot sustain all the needs. Sometimes we need to rely on such marine transportation of natural gas. So actually, for gas phase and liquid phased natural gas, the volume ratio is roughly around 600 to 1. That means you can save a lot of space when you are transporting gas. For example, just now we mentioned total capacity of the ship is around 170,000 cubic meters. When you have gasified all those capacity, you're going to have over 100 million cubic meters. So from that, you can tell how much space you can save. So it is much easier to transport. We have worked quite a while, exactly. So we have worked the length of 2 football court. So the total length is around that of 3 football court together. This is the head of the ship. You can also find a lot of equipments are being put here. This is mainly for the parking, for the docking of the ship of the gas carrier in a port. You can find there is an anchoring machine. So the cables you are using are really thin ones. It is different from the bigger ones, right? You can tell that the cable on the other ship is actually bigger. As for LNG gas carrier, loading and unloading have to really be safe and reliable. And there might be some safety concerns when you unleash the cable. So we want to make the cable thinner to prevent some accidents from happening. So what can you show us in this part of the vessel? So this equipment right here, as you can find, actually for someone who's not very familiar with shipbuilding, they look all the same. So this is also a ventilation post. When you are maintaining the ship, you have to open it up. And you have to get the LNG out of the host space. As you can find, there is a tiny room here. This is for fire-proof. You have the powder fire extinguisher here that you can use. And you also have the pipes here. So we have several fireproof kiosks here. We have adopted a very high level of fire protection on this vessel. Yeah, I can see another few kiosks like this on the deck. In front of us, there is a platform for helicopters. So when there is an emergency happening, usually helicopters will be used. For example, when we need to have a repairing engineer transported to the vessel, or we have some staff or crew members who have to be evacuated from the ship, they can take the helicopter. So there are so many pipelines on the deck. On your right-hand side, you can find the pumps. And you can also find all the LNG liquid phase pipes being concentrated here. For liquefied natural gas, there will always be a platform for helicopters, right? Actually, previous designs didn't include such a platform for helicopters, but for the newest design in the world, you can find such a reservation. That's mainly for the safety concern, so that you have to provide a platform for helicopters. We have a symmetrical design on the ship. Just now, you can find the left side and the right side of the ship. This room here, it is the space to host all the replacement parts and the components of the ship. So what's inside this tiny space? So we have some, just now we mentioned the replacement parts and the components being stored in the room, and the door is locked. So sometimes there will be some sealant parts, or there will be some screws and bolts that have to be replaced. And just in case, we will store such parts and components in this space. So all these liquid phase and the gas phase pipes, sometimes they have to be maintained regularly. So maybe the signal will not be that good inside this space. There will be some shielding caused by the walls. This is mainly the control center for the pipes. Can we go this way up? So all the pipes they are put in this room. So most of these equipments here are localized for production in China. As you can tell, there are a lot of pipes, and they are all insulated. So it's mainly the pipes for LNG, right? Yeah. So what's next door is the electrical control room. Maybe we can also pay a visit to that room. The compressor is here. So why you have a compressor here? So when there is a gasification of the liquid natural gas, then they have to be compressed so that it can liquefy again. So this is about a reliquefaction process. There are even more pipes here. So the next stop will be another closed space. And we're going to find out how these LNG will be maintained in the state required. And if gasification really happens, it will be quite dangerous. Just imagine the gasification will require a lot more room for the storage. And going into this space, maybe the signal will be even poorer. Exactly, the shielding of the iron gate is quite strong, so the signal may deteriorate. And we can go inside. So there are two doors, and you have to follow the protocol to close the right door at the right time. I'm sorry about the signal being quite poor here, and there might be some latencies. So this is the nitrogen system here. We have a compressor of nitrogen here, and the nitrogen system is about the liquefaction, as we've mentioned. And just now you asked the questions about another compressor over there, but this is another compressor. And this compressor can help us to cool the gasified LNG with the liquefied nitrogen. For the gasified LNG that's left, they can be liquefied through this nitrogen system. So maybe the signal here is too poor, so we have to go outside, just to give you a rough look of the inside. We've heard the alarm. So the protocol is quite strict. You have to make sure that the two doors won't be open at the same time. When you open the two doors at the same time, there will be an alarm being set off. So just now we have taken a look at this nitrogen system, which is to provide some temperature maintenance for the liquefied natural gas. Actually, it is more about liquefaction. It is about lowering the temperature and to turn all this gasified LNG into liquefied form again. So during transportation, there will be some volatile conditions such as shaking of the vessel body, and there will be some gasification taking place, and we have to make sure that the natural gas will be maintained in a liquid phase. Exactly. Because we want to minimize the evaporation of natural gas. We don't want to emit a lot of natural gas into the environment. Just now, we've already taken a look at all these equipments and all the cabinets on the vessel, and maybe the next step we will have a closer look at how the crew members are working on the ship. This way, please. We can go inside. Maybe the signal will go bad again inside the room. So we can look at the canteen for some senior staff, because most of the staff they will come from different countries. And you know how boring it can be to live on a boat. So sometimes we to live on a ship. So we want to make sure that they can enjoy a comfortable life as much as possible. We want to offer some special treatment in terms of dining for all of them. And we have two Western-style canteens on the vessel. So now we are very close to the Shanghai port. So all the lifesaver boats are being hung here. Because this vessel now is actually on the surface of the ocean, so the signal sometimes is really poor. But certainly you can say this is really still jumbo on the surface of the ocean. We just took a look at the canteens, and we want to learn about how the staff and the crew members are having their daily life here. And now we are in open air, so the signal can be a little bit better. So where are we exactly? Now we are very close to the cabinet. It is like the central control of the vessel. You can take a look. When you are driving a car, you have the driver's seat. And what about a captain? You can have a well gas where the captain will be seated. Actually, you're right. This is the spot for the captain to drive this vessel. And you can find we have dashboards with meters, with GPS, with radar, an electrical system. You can also find CCTV monitoring and the locationing system. You have the camera system. So what is this? This is just like a electronic compass for the captain. And this is the propulsion system, right? Exactly. So there are two propulsion systems. With this one, we can control the speed. We can also change gears. For example, you want to go forward or you don't want to go backward. And you have a total number of 26 crew members. There are crew members from Europe, from Southeast Asia, from South Asia, etc. It is really like a team of multinationals. We can go to a smaller platform right there to take a look at a very interesting equipment. So, what is this? It is just a part of the electronic compass. It looks very special. It seems there are two parts in this electronic compass. We can see inside the compass. So with the compass on the top, the crew members can tell the direction when sailing, and you also have a conventional magnetic compass on the ceiling. So to have all these compasses, you can make sure there are some fail safety. Exactly. You can also find a lot of graphics here. This is really like the brain of the vessel. So how can you monitor what's going on inside the host space during transportation? We can go to the freight control room. It is downstairs, and later we can take a look. So the captain will be standing there, right? So in most cases, the captain can also sit here, or he can choose to stand up. So you also have the XO and other crew members doing important operations on the dashboard. Exactly. When there's something really important, you have the captain to make the moves. Right. But in most cases, the captain will not be involved with daily operations. And you have the so-called drivers for the vessel to do that. So it is really like a cruiser, right? We can also go this way. You have a brilliant view here. And when you look at the other two sides, you also have to observe the conditions on the two sides of the vessel. So you have the dual wing platform like this, where you can check out the situation on the two sides. It's just like the two wings of the bird, and you have an operation platform here, which can be connected with the central control. You can also control the vessel with this platform, especially when the vessel is going to be docked in a port, or it is going to be undocked. And when it gets closer to the port, you can find to have this kind of dual wing design, it is going to be much easier for the vessel to be docked. You can make a more accurate judgment of the positioning of the vessel. Exactly. There are also some poles here. So what does it serve for? So it looks like a lighting device, and you can turn it on to take a look. It might be locked. So it's also part of the compass system. Yeah. So what's this? All right. Just now, we couldn't really turn around that device, but when the ship is in operation, I think it is going to work, right? Exactly. You have much stronger crew members who can turn it around. So let's take a closer look at this. It's not an antenna, it's not a lighting, but it's an electronic compass. And with this one, we can have a closer understanding of the positioning of the vessel. So it is electronic, yeah. And you can also look at the control system here. It is a smaller operation platform. It serves the same function just like the system in the central control room, but it is more compact in design. So all the functions are being put on the platform. You have the two propulsion systems here. And you can also tell what is the wind velocity and the direction of the ship, and also the depths. and the draught of the ship. Now this ship is being docked in the port, so the draught is not that deep, but when it is sailing, it's going to be deeper. So you can check out all the important information on this dashboard here. Exactly. You can have a better control of the conditions. So the two propulsion systems have two engines. Exactly. It's really a special design, right? Because this is a larger gas carrier. What about regular sized ships? Actually, for regular sized ships or vessels, they don't have to be so demanding. But for Pan-Africa, this gas carrier, it is really adopting most of the most advanced technologies in Chinese shipbuilding industry. Now we can go to the freight control room to take a look. So how long have you served on this ship? What's your experience with the vessel so far? Technically speaking, I'm more of a BD person. We have around a team of around 10 people who have been spending years on site for better communication. There is also a swimming pool. Just to make the life of crew members easier. And we can check out where is the swimming pool. So on the left-hand side, there seems to be a pit. So what's inside the pit is the swimming pool. Sometimes you can have the crew members to enjoy some sunshine and do some swimming here. So how deep is it? It is around 2 meters. And the total area of the surface is around 7 to 8 square meters, just to provide a little bit of relaxing space for the crew members. But our understanding of a swimming pool is that it should be an open space, but this one seems to be a little bit too compact, and there is a very big wall right next to it. You have to understand we are building a swimming pool on a big vessel. When designing the swimming pool, we thought about how to bring some good experience to the crew members, but there are a lot of limitations that you have to respect on such a big vessel. But I do believe this is going to be providing some relief and good time for the crew members. Now we can go to the freight control room. It is going to be the place where the concentration of the liquefied natural gas will be controlled and monitored. So's the temperature. Without you, as a very experienced guide, we might get lost on this big vessel because there are so many stairwalks. Now we can go to the next floor. Now we are about 20 meters high above the surface of the water. Yeah, it's about 15 to 16 meters. So we can go through this passage and we try to find a place where the signal is reliable. So this is the freight control room. For LNG gas carrier, what matters most is the freight control system. So the freight control room is really the brain for the controlling and monitoring of all the freight on this vessel, and all the commands and operations with regard to the freight will be conducted here. You can find out all the commands, modules, and you can also have a monitoring of the overall situation of the freight. You have over 4,000 monitoring spots on the vessel, and with monitoring all those different spots, you can tell what is the condition of the freight. You can look at this. It is more intuitive. So there are 4 different tanks, like we mentioned, all the cargo tanks. And now the ship is not loaded. You can find that this is the pressure, which is 0.6 Pascal, and you can also find the nitrogen is already pumped in, and the temperature can also be found here. Now the temperature is not as low as minus 162. Now it is minus 9. So when the vessel is put into operation, the temperature is going to reach that low of minus 162 Celsius degree. And for the existing nitrogen inside the tank, they will be replaced with natural gas. Temperature of the freight, as we mentioned, which is liquefied natural gas, has to be maintained at minus 162 Celsius degree. So, like we've mentioned, this is really the brain for the freight control. So what's the most challenging part when it comes to the control? You have to make sure that the temperature and the pressure are kept at the right level for the freight. When loading and unloading the liquefied natural gas, you also need to bring a perfect match of the pressure of the receiving end and the transmitting end. So what equipments are designed especially for liquefied natural gas? All these monitoring system is really designed specifically for natural gas transportation, and you can also find some solutions when there is some abnormal situation. Now maybe we can go to the captain's room. I'm just afraid that a signal may be shielded again. I'm really curious what's the setting for the captain's room. So the captain has closed the door, and it is just a little bit pity for us that the captain's room has to be kept in secret, and he has locked the door, so there's no chance for us to enter. his room. And maybe next time we can be invited to take a look. And we can ask him for the honor of going into the captain's room. And we are even more curious where is the safe of the captain. We want to take a look. So just now we had a rough look of the LNG gas carrier. We talked about what are the difficulties and the challenges to build such a vessel, and we also mentioned now liquefied natural gas is very important in China's energy security. And for the next step, Mr. Huang from CNOOC can share with us who have contributed to the efforts of building this giant ship. And are there some stories that you want to share with us, or some valuable memories? A colleague of mine is called Zhang Haitao, and he actually broke his torch. It's actually a flashlight. So he actually broke his flashlight just in 1 month. And sometimes when you have a flashlight, you can use it for years. You never thought it could be that easy to be broken. So we all were very curious why you broke your flashlight in only 1 month. And his answer is that he has to use the flashlight all the time. He has to check everything, and he turn on and turn off the flashlight all the time. Every day he has to walk almost 10 kilometers on the deck. And he also has to climb up and climb down. It's like climbing a building of a score floors every day. So that's something that really touched me. So just now you mentioned the welding technology is very advanced. So for all the welding seams on this vessel, it is 200 kilometers long. So the requirement for the welder will be very demanding. So when a welder is about to get on board, we will ask questions such as how are you feeling now? Did you have a fight with your wife last night? So if there is any psychological issues with the welders, we will make sure that he can return to his best state before he gets to work. So it is really very demanding for the welders to do a good job, because this is highly challenging from the technical perspective. And there are so many different requirements, as you've mentioned. For example, the temperature, the technique, and the psychological conditions of the welder. So, Mr. Engineer, what is going to be the future of this vessel? So for the PU series, there are 4 vessels in total. This one is the Pan-Africa, and there are 3 other vessels. So can you give us some introduction? So there are 4 vessels in total. We have the Pan-Asia, Pan-America, and Pan-Europe, and Pan-Africa. Every year, their transportation capacity will reach 8.6 million tons of LNG. In 2018, China imported 50 million tons of LNG, and with the 4 vessels we've mentioned, they can actually meet up to 1/6 of the total capacity. So now, there are already 10 major liquid natural gas carriers in China. With the demand for clean energy going up in China, we will have the necessity to build even more major LNG gas carriers like this. And we are also working on the secondary secondary transit capacity. Usually, when the LNG is imported to China, there needs to be some transit facilities, and with the transit facilities, the capacity can be further transported to other locations in China. And we are also planning for all these LNG filling services around the Yangtze River and in coastal areas of China. We try to localize every single link in this industry, and we also want to make shipbuilding industry in China really the best of the world. Clean energy, green development, these are major agenda in China. At the same time, we also want to maintain the energy security for China, and we want to make our contribution in that. Thank you so much, Mr. Huang, for a very long live streaming together with us. So we have learned about everything. The history of liquefied natural gas carrier and why we are doing this.